Bonding the grounding conductor to a metal box that is attached to a wood joist in a residential structure wired with NM cable is required for several important reasons. Firstly, safety. By bonding the metal box to the grounding conductor, any fault current that may occur in the circuit will be safely directed through the grounding path, minimizing the risk of electrical shock or fire. Secondly, compliance with electrical codes. Electrical codes, such as the National Electrical Code, require all metal boxes, regardless of their mounting location, to be bonded to the grounding conductor to ensure proper grounding and fault current protection. Thirdly, electrical grounding. The grounding conductor provides a low resistance path for fault current to flow back to the electrical service panel and safely dissipate into the earth. Bonding the metal box ensures that this grounding path is complete and effective. Fourthly, electromagnetic compatibility, abbreviated EMC. Bonding the metal box also helps reduce electromagnetic interference, abbreviated EMI, by providing a conductive path for any stray currents to flow. This can minimize potential interference issues with other electrical devices or communication systems in the area. Fifthly, continuity. The bonding connection ensures that the electrical grounding system remains continuous throughout the circuit, from the electrical service panel to the metal box and all connected devices. This continuity is essential for proper operation of circuit protection devices and grounding fault protectors. To elaborate further, let's consider each of these points in more detail. On the topic of safety, in a typical electrical circuit, current flows from the source through the load and back to the source. However, if a fault occurs, such as a wire coming loose and touching the metal box, the electricity will try to find a path to ground. If the metal box is not properly bonded to the grounding conductor, this could result in the metal box becoming energized, posing a significant electrical shock hazard to anyone who touches it. By bonding the metal box, you provide a low impedance path for the fault current to flow back to the source, tripping the circuit breaker or fuse and quickly de-energizing the circuit. This significantly reduces the risk of electrical shock and fire. Regarding compliance with electrical codes, the National Electrical Code, the NEC, and similar codes in other regions are in place to ensure the safety of electrical installations. These codes are developed by experts in the field and are based on years of experience and research. The requirement to bond metal boxes is not arbitrary, it's a fundamental safety measure that has been proven to be effective in preventing electrical hazards. It's important to adhere to these codes to ensure that your electrical system is safe and compliant. Concerning electrical grounding, the grounding system serves as a reference point for the electrical system, ensuring that all non-current carrying metal parts are at the same potential as the earth. This helps to prevent voltage differences that could lead to electrical shock. The grounding conductor is connected to the grounding electrode system, which typically consists of ground rods or metal water pipes buried in the earth. When a fault occurs, the grounding conductor provides a path for the fault current to flow back to the source and trip the circuit breaker or fuse. Bonding the metal box to the grounding conductor ensures that the grounding path is continuous and effective. Turning now to electromagnetic compatibility, electrical devices can generate electromagnetic interference that can disrupt the operation of other devices. This interference can be radiated through the air or conducted through electrical wires. By bonding the metal box, you create a conductive shield that helps to contain the electromagnetic interference and prevent it from affecting other devices. This is particularly important in sensitive environments such as hospitals or laboratories where even small amounts of interference can cause problems. Finally, continuity is crucial for the proper operation of the grounding system. The grounding system must be continuous from the electrical service panel to all electrical equipment and devices. This ensures that there is always a low impedance path for fault current to flow back to the source. If the grounding system is not continuous, a fault current may have to travel through a high impedance path, which could limit the amount of current that flows and prevent the circuit breaker or fuse from tripping. This could result in the metal box remaining energized and posing an electrical shock hazard. Failure to properly bond the grounding conductor to the metal box could compromise the integrity of the grounding system, increase the risk of electrical hazards, and violate electrical code requirements. It's important to take the time to properly bond all metal boxes to the grounding conductor to ensure the safety of your electrical system. In practice, bonding is typically achieved using a bonding jumper wire that connects the metal box to the grounding conductor. The bonding jumper wire should be sized appropriately for the circuit and should be securely connected to both the metal box and the grounding conductor. There are various methods for connecting the bonding jumper wire, such as using a screw terminal, a crimp connector, or a listed grounding clip. It's important to follow the manufacturer's instructions and use the appropriate tools and materials to ensure a reliable connection. It's also important to inspect the bonding connections periodically to ensure that they are still secure and free from corrosion. Over time, connections can loosen or corrode, which can compromise the integrity of the grounding system. If you notice any problems with your bonding connections, it's important to repair them immediately. In summary, bonding the grounding conductor to a metal box is a fundamental safety requirement that is essential for protecting people and property from electrical hazards. It's important to understand the reasons behind this requirement and to follow the appropriate procedures to ensure that all metal boxes are properly bonded to the grounding conductor. By doing so, you can help to create a safe and reliable electrical system. Now consider some practical scenarios. Imagine a ceiling fan installed in a residential bedroom. The fan is mounted to a metal pancake box attached to a wood joist. The wiring is NM cable, often referred to as Romex. If a hot wire inside the fan motor were to come loose and contact the metal housing of the fan, and the metal box were not properly bonded to the grounding conductor, the entire fan housing could become energized at 120 volts. Anyone touching the fan would be exposed to a potentially lethal electrical shock. However, if the metal box is properly bonded, this fault current would immediately flow back to the electrical panel, tripping the circuit breaker and cutting off the power before anyone could be harmed. Another scenario involves a kitchen receptacle installed in a metal box. If a wire inside the receptacle were to come loose and contact the metal box, and the box were not bonded, the metal box could become energized. This could create a shock hazard for anyone touching the metal box or any appliance plugged into the receptacle. Again, proper bonding ensures that the fault current is safely conducted back to the panel, tripping the breaker and preventing a dangerous situation. Let's discuss the specifics of how to properly bond a metal box in a residential setting. Firstly, ensure the power is off to the circuit you are working on. Always verify the circuit is energized with a voltage tester before proceeding. Secondly, identify the grounding conductor within the NM cable. This is typically a bare copper wire. Thirdly, if the metal box has a grounding screw, connect the grounding conductor directly to this screw. Ensure the screw is tightened securely to provide a good electrical connection. Fourthly, if the metal box does not have a grounding screw, you can use a grounding clip or a bonding jumper wire. A grounding clip is a small metal clip that attaches to the edge of the metal box and provides a point for connecting the grounding conductor. A bonding jumper wire is a short length of wire that connects the grounding conductor to the metal box, often using a screw terminal or a crimp connector. Fifthly, when using a bonding jumper, ensure the wire is sized appropriately for the circuit. The NEC provides tables to determine the correct size of the bonding jumper based on the size of the circuit conductors. Sixthly, make sure all connections are tight and secure. Loose connections can create resistance and compromise the effectiveness of the grounding system. Seventhly, after completing the bonding, test the connection with a continuity tester to ensure there is a low resistance path between the metal box and the grounding conductor. If you are unsure about any aspect of bonding, consult with a qualified electrician. It's always better to be safe than sorry when dealing with electricity. Regarding specific NEC articles related to bonding and grounding, you should be aware of several key sections. NEC Article 250 covers grounding and bonding in general. NEC Section 250.4 addresses general requirements for grounding and bonding. NEC Section 250.8 specifies methods of grounding and bonding. NEC Section 250.148 covers continuity and attachment of equipment grounding conductors to boxes. These articles provide detailed requirements for ensuring proper grounding and bonding in electrical systems. It's important to consult the latest edition of the NEC for the most up-to-date information. In addition to the NEC, there may be local codes or regulations that apply to electrical installations in your area. It's important to be aware of these local requirements and to comply with them. Local codes may be more stringent than the NEC in some cases. For example, some jurisdictions may require additional bonding or grounding measures for specific types of equipment or installations. Now let's explore common mistakes to avoid when bonding metal boxes. One common mistake is failing to bond the metal box at all. This can happen if the installer is unaware of the requirement or simply overlooks it. Another common mistake is using the wrong size of bonding jumper wire. Using a wire that is too small can limit the amount of fault current that can flow and prevent the circuit breaker from tripping. A further mistake is making a poor connection. Loose or corroded connections can create resistance and compromise the effectiveness of the grounding system. Furthermore, another mistake is damaging the grounding conductor. The grounding conductor must be continuous and intact for the grounding system to function properly. Moreover, over-tightening the grounding screw is a mistake too. Over-tightening can strip the threads and compromise the connection. A different mistake is using the wrong type of connector. Using a connector that is not listed for grounding applications can create a safety hazard. And another mistake is ignoring local codes or regulations. It's important to be aware of and comply with all applicable codes and regulations. Remember, proper bonding and grounding are essential for electrical safety. Take the time to do it right, and if you are unsure about anything, consult with a qualified electrician. Regarding tools and materials needed for bonding, you will need a few essential items. Firstly, NM cable stripper. This tool is used to safely remove the outer jacket of the NM cable without damaging the conductors inside. Secondly, wire strippers. These are used to strip the insulation from the ends of the wires. Thirdly, a screwdriver. This is needed to tighten the grounding screws. Fourthly, a voltage tester. This is used to verify that the circuit is energized before working on it. Fifthly, a continuity tester. This is used to test the continuity of the grounding connection. Sixthly, bonding jumper wire. This is a short length of wire used to connect the grounding conductor to the metal box. Seventhly, grounding clips or connectors. These are used to attach the grounding conductor to the metal box. And eighthly, electrical tape. This is used to insulate any exposed wires or connections. Always use quality tools and materials that are listed for electrical applications. Cheaper substandard tools and materials can compromise the safety of your electrical system. Finally, let's recap the key takeaways. Bonding the grounding conductor to a metal box is a critical safety requirement. It protects against electrical shock and fire hazards. It ensures compliance with electrical codes such as the NEC. It provides a low impedance path for fault current to flow back to the source. It helps to reduce electromagnetic interference. It ensures continuity of the grounding system. Failure to properly bond the metal box can have serious consequences. Always take the time to do it right, and if you are unsure about anything, consult with a qualified electrician. Safety should always be your top priority when working with electricity.